part of our right triangle trigonometry unit here that we're going to be taking a look at. Sine, cosine, and tangent, abbreviated as what you guys would probably call sin, cos, and tan. So you've got three buttons on your calculator. You probably always wondered what the heck they were for. It's the button says sin, it says cos, it says tan. They're all right in a row. We're going to find out what they're for in the next couple of days here. It actually helps us out in terms of figuring out angle and side measurements of right triangles. So on the board here you'll see I've got three triangles drawn out. They're all right triangles. I've got 9, 12, and 15, 6, 8, and 10, and then the small one here is 3, 4, 5. Basically we're going to just talk a little bit about similarity again. We talked about that in our last chapter, and you can see I've got the little similarity symbols in between all the triangles because all three triangles are similar to each other. Alright, so remember what that means. It means that corresponding sides have to be proportional and that the corresponding angles have to be congruent to each other. Well, obviously, all three of the right angles will be the same. Angles A, D, and G should all be the same, as well as angles B, E, and H. Why is that important? How does that pull in the trigonometry? Well, I'll show you a little bit today. If you take a look and we focus in on the top three angles here, if we focus in on A and D and G, and if we look at the side that is farthest away from those angles, in this case 12, 8, and 4, that's going to be called the opposite side from those three angles. If we compare that opposite side to its hypotenuse, so here 12 to 15, here 8 to 10, and the small one 4 to 5. Notice that if we take each of the first two ratios and reduce them, 12 over 15, that's 4/5. 8 over 10, that's 4/5. They all end up having the same ratio when you focus in on that angle. Now, if we take a look at angle B, and we look at opposite, the side opposite from that angle, in this case 9, compare it to the hypotenuse. Angle E, focus in on 6, compared to its hypotenuse, 10. Here's angle H, the farthest side away from it, 3, compared to its hypotenuse, 5. Again, if we reduce 3/5, 3/5, and of course already 3/5. That's important that those ratios all end up being the same thing. And it should kind of make sense because what did we just get done saying? All three triangles are similar, which means that angles A, D, and G are all the same, hence the reason why they've got the same ratios. Angles B, E, and H are all the same, hence why they have all the same ratios. So it kind of ties into our little trigonometry unit that we're going to get into pretty hard right now. So this opposite and hypotenuse ratio I just showed you, that's what we call the sine ratio. It's always the side opposite the angle over the hypotenuse. We've got two other ratios that we talk about. The cosine, and don't forget, this is just a little angle symbol here. So it's the sine of an angle, and it's this ratio. The cosine of any angle would be the side adjacent to it. Okay? When you see me write A, D, J, that's adjacent. So the side adjacent to the angle over the hypotenuse. The tangent of an angle is the side opposite over the side that's adjacent to that angle. So we'll take a look at a couple examples. I'll give you a little way to try to remember all your ratios here as we go through. So we've got basically three examples we want to take a look at to get ready for tomorrow. We want to set up the trig ratios for both acute angles. So we'll look at angle A, we'll look at angle B, we'll look at angle S, we'll look at angle T. If you want to pause for a second and get all your example stuff set up here real quick on your notes, that's fine. Hey, so we've got a right triangle. Notice we only have two sides marked. We've got segment CB with a length of 5 and segment AC with a length of 12. We need to know what this third side is. How are we going to figure it out? That's right. We could use Pythagorean theorem and do a little a squared plus b squared equals c squared. I'll let you work that out. What you should find is that c should equal 13. And so that's the length of our hypotenuse. So if I start setting up my ratios, and I told you I'd give you a little way to remember it, the sine is always opposite over hypotenuse. The cosine is always adjacent over hypotenuse. And the tangent is always opposite over adjacent. So you got so, ka, toa. Right? So when you hear me say SOHCAHTOA, that's what we're talking about. And at this point I may or may not have already shown you kind of a little song that goes along with SOHCAHTOA. If I haven't, remind me and I'll show it to you guys while we get back in class. So we go to set up our ratios here. Sine of A. So here's angle A. So opposite angle A. So opposite means we're going to travel through the triangle all the way across. This would be opposite. Across the right angle, clearly that's the hypotenuse, which means the third side has to be the adjacent. So opposite 5, hypotenuse 13, there's my ratio. Cosine, adjacent over hypotenuse. So here I'm looking at the adjacent side, that's 12, hypotenuse 13. Tangent, opposite 5, adjacent side 12. So there are my 3 ratios for angle A. Now we want to do the ratios for angle B. Hypotenuse always stays the same. Now when I take a look at angle B and I go across, what was my adjacent side switches to my opposite side, and what was my opposite side switches to the adjacent side. So really, these ratios are going to look pretty similar, just maybe in a little bit different order. Sine of B. So when I take a look at the sine of B, opposite 12, hypotenuse 13. So there's my 12 over 13 again. So notice those two are the same. Cosine of B, adjacent over hypotenuse. So these two are the same. Tangent of B, opposite 12, adjacent 5. So here, 5 12ths, 12 fifths. That's right. Those are reciprocals. So tangents, always reciprocals of one another. Sine of A, cosine of B, same thing. Cosine of A, sine of B, same thing. So if you figure out the first 3, the second 3 are a lot easier if you can just kind of remember the pattern. Alright. So, here we've got another right triangle, triangle STU. Again, you see we're missing we've got 2 parts. We're missing that height, the altitude. And again, you can do some Pythag. This time though, we need the a squared plus 7 squared is 25 squared. So you're going to work backwards a little bit. What's that? It's 24? You're right. This side is going to be 24. So again, take a second. If we focus in on angle S, label your sides. Which one's opposite? Which one's adjacent? This is opposite. This is adjacent. So when I set up my ratios, opposite 7, hypotenuse 25, adjacent 24, hypotenuse 25. So again, we're going to see these ratios all over again. Tangent, opposite 7, adjacent 24. Sine of T, same thing as, that's right, cosine of S. So that means that this is going to be 24 over 25. Cosine of T, same as the sine of S, so that's 7 over 25. Tangents are just going to be what? That's right, reciprocals. So this is going to be 24 over 7. Alright? Hopefully you've got the hang of it. one last example. Go ahead and pause, set it up. Welcome back. So again here, I'm being crazy for you and not giving the hypotenuse. So here we got 6 squared, bad marker. 6 squared plus 6 squared equals c squared. We should find out that we get the square root of 72 equal to c. Simplify your radicals. That's right. 36 and 2, which means the square root of 36 is 6. You get radical 2. That's your hypotenuse. We're going to set these up one way, and we'll talk about how to simplify them when we get into class tomorrow. That'd be a good way to kind of start things off. So, again, here we're focused on D. Set up your opposite side, set up your adjacent side. That's right. Opposite, adjacent, hypotenuse. So opposite, 6 over your hypotenuse, 6 radical 2. Cosine, 6 over 6 radical 2. Tangent, opposite, 6 over the adjacent 6. Guess what? Follow your pattern. This guy goes here. This guy goes here.
We're leaving, you got her.
Yep. The reciprocal of 6 over 6 is 6 over 6. Doesn't change. So you're probably like, hey, dude, that equals 1. Yeah, it does. 6 on top, 6 on bottom. Those are going to cancel out, reduce as well. We'll take a look at that when you get into class tomorrow. Any questions? Go back through the video, rewind it, check it out, slow it down. Going slow-mo. That's slow motion. We'll see you tomorrow. Have a great day.